Hi again, 1103 students. In this video, I will be going through sections 2.2 and 2.3. So this 2.2 starts off with the Venn diagram. The Venn diagram is basically circles or ovals, and we're going to use that to show representation amongst different collection sets or different pieces of data and different numbers. Leonard Euler, he's the person that came up with the idea of the Venn diagrams. He wanted to use it to show the representation of different numbers, and we're going to discuss how the Venn diagram makes things a little more simple to look at and how it separates data. The following Venn diagram, what I have on this page is just simply show, it just has it out in words, then we're going to put it into the diagram. All right, so set U, that will be your universe. So X is such that all positive integers are less than 30. So the next diagram, we're going to do with numbers that are less than 30. The sets are defined as S is going to be a number or numbers that are divisible by 11. T will have numbers that are a perfect square, but they are less than 30. And V will have numbers that are greater than 2 and is a perfect square. So now we're going to use the Venn diagram to answer the following numbers. So list the elements in the sets S, T, and V. So when you look at S, you want numbers that are divisible by 11. That would be 11 and 22 because we're dealing with numbers that are less than 30. Okay, so S would be equal to the elements 11 and 22. Then you're dealing with T, that would be equal to perfect squares, and perfect squares would be 1, 4, 9, 16, 25. Perfect squares less than 30. And then V, the perfect cubes greater than 2. So these are the cubes. So that would have to be only 8 and 27 because 2 to the third power is 8 and 3 to the third power is 27. So B, S stands for, we want the cardinality. So how many terms, how many elements are in S? That would be only 2. So this would be 2. How many elements are in T? That would be 1, 2, 3, 4, 5. And how many elements are in V? That would be just 1 and 2, the 8 and 27. So we have to know that the absolute value means that's the cardinality or the number of elements in each set. So T, that means the complement of T. That means what is not in T. So the universe, this is the U, it has all numbers that are from 1 all the way to 30. So we have all of these numbers that are all the way to 30. So basically, if we want the complement of T, we're going to list everything that's not in the perfect square. Everything except 1, 4, 9, 16, 25. That's what we have to list. So that would be a large group of numbers, but we can do it. So we can list 1. No, we can't list 1 because 1 is a part of T. Sorry. So you're going to have to start with 2, 3. Can't put 4 because 4 is a part of T. And then it'll be 5, 6, 7. Can't put 9. Then you have to go to 8. Excuse me. 10, 11, 12. 13, 14, 15. Can't put 16, but you can put 17, 18, 19, 20, 21, 22, 23, 24. Cannot put 25, but you can put 26, 27, 28, and 29. Everything except what is in T. Okay, now the S equals V and S equivalent. So when you look at the terms of S has 1, 2 terms, and V has 1, 2 terms. So would that be equal or equivalent? It would be equivalent. They are equivalent because the numbers are not the same, but the cardinality is the same. All right, next. An increasing number of electric vehicles are on the roads in the United States. The number of charging locations available for each cars varies from state to state. The 5 states with the most public and private electric charging stations are California, New York, Florida, Texas, and Massachusetts. So what we have here, this is just everything written out in set builder notation for the universe. And then we have California, New York, Florida, Texas, and Massachusetts. These are different states. So let's go to the next part. Make sure everything is still recording. All right, so this is the diagram, and you're dealing with California, New York, Florida, Massachusetts, and Texas. So these are the different charging stations in each of the different states. So the next question asks, which state has the most charging stations? It would be California. So California has the most. Which state has the second highest? That would be New York. That has the second highest. And C says how many electric charging stations locations does the excuse me, how many electric charging locations do these 5 states have altogether? So therefore you would add up 13,826, 2,733, 2,477, 1,872, and 2,199. When you add that up, this is for part C in the next slide, you would have 23,107. That's how many charging stations are within these 5 states. Now, part D asks, how many charging locations are in the United States but are not in one of the 5 states in the diagram? So in order to find that, you take the universe, because that is how many in the total United States altogether, and minus the 5 that we have total that we totaled in part C. So this would be 46,848 minus 23,107. So that will give you a final answer of 23,741. That is how many charging stations that are in the US but are not in one of those 5 locations. And these are the questions I just answered. So the next Venn diagram. List the elements in a complement. So that means what are the elements that are not in A? So it seems like, ooh, maybe a little difficult, but it's not. All of these are in A. So the only numbers not in A would be 1, 2, and 3. These numbers and number 1. So that will be the complement. So remember, A with apostrophe means the complement are not. Subset. Let A and B be sets. So set B is a subset of A if every element of B is also an element of A. This is notated by like a C with the line. That's a subset. Just basically means something inside of something. So every set is a subset of itself. The empty set is a subset of every set. So remember that even though it's empty, nothing is there, it's also a subset of every set. So I'm going to tell you this is in words, but and I'll explain more. All right, so the School of Orchestra is divided into 4 sections: the strings, woodwinds, brass, and percussion. So let S represent the 4 instruments in the string section. So we only look at the string section. So you have violin, viola, cello, double bass. So that's 1, 2, 3, 4 items. So what they're basically saying, what I will ask you is how many items are in the subset. And we're going to find out in just a few moments that this is a formula. 2 to the nth power will tell you how many items you have in a subset. And the n stands for the number of items in your set. So this is 1, 2, 3, 4. So this will be 2 to the 4th power, which is equal to 16. So you will have 16 different ways of pairing those things together. And so this is what it's talking about when it tells you how to pair them together, and how the different words, violin, cello, cello, violin, that will still be a pair. And so this table is when you list out all the subsets, and if you count them up, you will have 16 subsets. But if you use that formula I just gave you, 2 to the n power, that will tell you how many subsets. So I would want to know the quantity versus you listing them all out. All right, so hey, not equal, it has a slash through it if it's not a subset, and proper subset, if it's not a proper subset, it will have a slash through that as well. So now you just heard about proper subset, so let's see what that means. Basically, it is going to be a subset, but the quantities will differ. The quantities will differ. They're not going to be the same thing. All right, so what do I mean? Let M equals A, B, C, D, E, F. Determine if the following sets are proper subsets of M. So basically, A, B, and F, you see, they're all inside of this one. So yes, this will be a proper subset. C, this is inside of here. So yes, and these are proper because in N we only have 3 elements, but in M you have 6 elements. So therefore the quantity is different. So yes, they are proper subsets. Now for R, A, B, C, D, E, F, that's the same as this. So this is no. This is not a proper subset because it is the exact same thing. And for C, this is a no also because it contains H. H is not even in M. So that is your difference between the proper and non-proper. Now for the proper subsets, there's a formula that I'm just going to tell you. I will give you like Brazil, Vietnam, Colombia, which are the top 3 coffee producing countries in the world. All right, list of proper subsets. Yes, so in the next overhead, you'll see how they match all these up. Brazil will go with Vietnam, Vietnam with Colombia, and just make sure you have a different representation. But when you're doing the formula, if I ask you how many proper subsets between these 3 countries, you can use this formula, 2 to the n power minus 1. N again is how many elements you have in that set. So that would be 2 to the third power minus 1. 2 to the third power, which means 2 times 2 times 2, not 2 times 3, is 8. And 8 minus 1 equals 7. So that's how you know you have 7 proper subsets. And remember, the empty set is always a subset of every set. So that is the overarching idea, is that 2 to the n means subsets, and proper subset has the formula 2 to the n minus 1. So if I ask you how many proper sets, if you have A, B, C, and D, you would do the same situation. 2 to the n power minus 1, and you have 4 numbers. Oops. So that would give you 8 minus 1, which would be 7. And on this next, you will see if you put all the different, you have to include your empty set and then do them all individually, then pair them up in different pairs, and you will get a total of 8. And this is the definition and formula for proper subsets. All right, so Dr. Williams is eating at a local buffet one afternoon and noticed a sign that says, "So many possibilities. You could spend a lifetime eating at our buffet and never have the same meal twice." He wonders how many different meals he could make from 16 items on the buffet. He can have all, none, or some of the items. Determine the number of different meals he could make at the buffet. So that's how many subset could Dr. Williams make? There will be 2 to the n power, which would be 2 to the 16th power. And I hope you know how to put the 16th power in your calculator. Use the power key. And so 2 to the 16th power will give you 65,536. Yes, we do not want to do 2 times 2 times 2 times 2 16 times. Oh, that's a lot. So we're trying to work harder and not we're trying to work smarter and not harder, sorry. Okay, so now we're going to look at 2.3 with more of our lovely sets. So 2.3 is going to start off with intersection. So this is another something that you may want to write down. You keep your different symbols. This is the intersection symbol, and it's like an upside down U. So this is the intersection upside down U. And so basically that means what they have in common to both sets. So we look at A. Find the intersection of sets A. That means I'm going to look at these numbers here and this set of numbers here. What do they have in common? Nothing but 2. So if you would write A as an intersection with B, only to be element of 2. That's all they have in common. Part B, interpret the intersection of the sets in the Venn diagram in figure 2.3.2. So the intersection, now we have jobs that require a college degree and jobs that pay over $25. So the answer would be this intersection would mean that this person has a job where it means that jobs that require a college degree and they pay over $25 an hour. So that just means what they have in common. That means you're joining these two together. You have a college degree and you make over $25 an hour. So we can also use a Venn diagram to find the intersection. So here, we can look here. You may have noticed that, A is a list of the first 6 prime numbers, and B is a list of the first 6 positive numbers. And so what do they have in common? 2. 2 is the only prime number that is even because 2 only has 2 factors, 1 in itself. So here, Harvard Law School has produced more Supreme Court justices than any other law school. Use the Venn diagram below to interpret how many of the sitting justices as of August 2021 graduated from Harvard Law School. So basically what do they have in common? You graduated Harvard, and the justices that are and those who are Supreme Court justices, that will be 4. So it's 4 that are amongst the living graduates of Harvard and who are currently Supreme Court justices. So it's just looking at the Venn diagram, identifying what's in common. So here, this is intersection as well. So what 2 numbers, when you look at the list of numbers in A and B, they have 2 numbers in common, the 213 and 27. So this would be 27 and 213. These 2 are the numbers that are in common. All right, now we have disjoint. We have disjoint numbers. That means it's an empty set. They don't have anything in common. So when you look at this disjoint set, this example of disjoint sets can also be represented by a Venn diagram where the overlap between the sets are empty. So here, there is empty because there is nothing in common. So this here is a question. You have students with a GPA of less than 2.5. And then you have students with a GPA of greater than 3.0. So think about it. Can those be combined? If your GPA is less than 2.5, could you be the same as a person with a 3.0 or higher? Well, higher than a 3.0. Nope, they are 2 different situations. You cannot combine them, so they will be 2 different situations. So this is a disjoint set because there's nothing in common that you can put them together on. So now we go to the union. The union is when I like to say unite, or you put it all together, or put all together. So the biggest thing is remembering what the symbols mean. So Sarah lived in Ohio, Pennsylvania, and Michigan. Her friend Trevor has lived in Colorado, Ohio, and Georgia. Her friend Ron has lived in Washington and Ohio. Let the residential locations of each friend be represented by the following sets. And that's what we have below. So now we're going to find A. So this means if you combine Sarah with Trevor, so Sarah would be in the Ohio, Pennsylvania, Michigan, And then Trevor would be in Colorado. But see, this is the thing, they repeat Ohio, so you do not write Ohio again. So, and you would just put the Georgia. Whatever they have in common, you don't, whatever overlaps, you only write. You just put it together, but you don't write it twice. So we have Ohio, Pennsylvania, Michigan, Colorado, and Georgia. So now you combine Sarah with Ron. We will have Ohio, Pennsylvania, Michigan, Washington, and Idaho. They just put all of those together. They did not have anything overlapping, so you just write them out separately. I mean, we'll write them all together. Write them together. So here we go. We have let you be the students enrolled at MLK High School. A is you have the student band, and then you have students that are in government. So if you combine them together, what can you have? Basically, you would have students who are in band or students who are in government. So you put them together. You don't have to worry about listing anything out because we don't know who those students are. So you just say, these are these. This is when you put them together. That is showing the demonstration of the students combined together. Okay, so this concludes section 2.3. So I will look forward to teaching you in the next sections to come.